coordinate geometry, we're going to name some quadrilaterals here. So to classify a quadrilateral as a parallelogram, rectangle, rhombus, or square, use the following steps. So step one is to check the congruency of the sides. And then step two, you're going to check the congruency of the diagonals. So the first case is a parallelogram. That's where your opposite sides are congruent and your diagonals are not congruent. Case two, for a rectangle, you have opposite sides that are congruent and diagonals that are congruent. Case three is a rhombus. All four sides are congruent and diagonals are not congruent. And case four is a square. All four sides are congruent and diagonals are congruent as well. So refer back to this diagram if you forget your quadrilaterals. So the main thing here is we have to figure out what the distances are. So we're going to have to use the distance formula. So we're going to practice here. Given the vertices, determine the quadrilateral's most specific classification. So is this a parallelogram, a rectangle, a rhombus, or a square? Actually, just to go back up here, let's do this. So this, for a parallelogram, you must have two sides that are congruent, um, opposite sides are congruent, I mean, and these diagonals are not congruent. For a rectangle, you would have opposite sides that are congruent. So these are congruent and these are congruent, and then plus your diagonals are congruent as well. Case three is a rhombus. You have all four sides that are congruent, but your diagonals are not congruent. And then case four is a square. All four sides are congruent, and then your diagonals are also congruent. Okay, so I'm just going to go like that here as well. So those are your congruent lengths as you go through these. So we have to use the distance formula. Remember that the distance formula is, I'm just going to write up here, d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so that's our distance formula. So also what you need to remember is that these are in order. It gives you A, B, C, then D. So whatever quadrilateral this is, mine is not going to be very good. We start with A and you go clockwise. A, B, C, and D is the order. So we can tell that AB is one side and DC is the opposite side to that, whereas AD and BC are the opposite sides there. And likewise, DB would be a diagonal and AC would be a diagonal. So I think it's important to have this diagram so that you can refer back to it. Okay, I'm going to make my pen a little skinnier here. So we need to figure out the distance of AB. So to figure out the distance of AB, that is going to be the square root of 9 minus 8 squared plus -4 minus -2 squared. So that would be equal to, I'm going to try to condense this as much as I can. 9 minus 8 is 1. 1 squared is 1. And then we would add -4 minus -2 is actually +2. So that would be -2. And then -2 squared is 4. So this one would be the square root of 5. We'll just leave it like that. And then we'll figure out CD, the square root of, CD would be the square root of 2 minus 3 squared plus -5 minus -7 squared. So that would end up being 2 minus 3 is -1, -1 squared is 1, -5 minus -7 is the same as +7, so that would be a -2, a +2, and +2 squared is 4. And so we do get the square root of 5. So we now know that these are congruent sides. So how about we need to do these two, BC and AD. So BC is equal to the square root of 8 minus 2 squared plus -2 minus -5 squared. So 8 minus 2 is 6. 6 squared is 36. And -2 minus -5 is the same as -2 plus a positive 5. That would be 3. And then 3 squared is 9. 36 plus 9 is 45. Okay, and then we just did BC, so we need to do AD. AD would be the square root of 9 minus 3 squared plus -4 minus -7 squared. 9 minus 3 is 3. 3 squared is 9. -4 plus a positive 7 is 9. Oh, I think I made a mistake here. Let's erase this because 9 minus 3 is 3. Is not 3, it's 6. 6 squared is 36. Okay, that's better. And then -4 plus a positive 7, that would be 3, and 3 squared is 9. So this ends up being the square root of 45. Okay, so now we know these two are now the same as well. So that makes these congruent. So now, is it a rectangle or a parallelogram? Because rectangles and parallelograms, if you remember from up here, they're the ones that are, you have opposite sides that are the same, but they're not all the same. So far we have opposite sides are congruent. Now we need to check the diagonals. So if we check the diagonals, then that would be AC, that would be the first one, or one of them. AC would be 9 minus 2 squared plus -4 minus -5 squared. So 9 minus 2 is 7. 7 squared is 49. And then -4 minus -5 is the same as 1. And that would be the square root of 50. Okay, so that was AC. We know that that's the square root of 50. So now we need to do DB. And if DB ends up being the square root of 50, then we'll know that it's a rectangle. Otherwise, it'll be a parallelogram. So DB is, let's see, 8 minus 3 or 3 minus 8. It really doesn't matter which way you go. I'm going to start with B. So 8 minus 3 squared plus -2 minus -7. We square that. So 8 minus 3 is 5. So we end up with 5 squared, which is 25. -2 minus -7 is the same as adding 7. So that's also 5. And 5 squared is 25. So we end up with the square root of 50. So we just proved, because these two are congruent, that it's a rectangle. So ABCD is a rectangle. Okay, so we just have lots of distance formulas for these. And I think it's just important to remember that they go in order. So QRST, since it's labeled that way, QRST, it goes like this, QRST, clockwise. So that way you know which ones are which. So we need to figure out, is QR and TS, are those congruent? So QR, we would have QR is the square root of -2 minus 1 plus -7 minus -5. So that equals -2 minus 1 is 3. 3 squared is 9. -7, if we add a +5, that's -2. And -2 squared is 4. So we would have 9 plus 4 under there. So that's the square root of 13. And then we need to figure out ST. So ST is equal to 4 minus 1 squared plus -7 minus -9. So 4 minus 1 squared is 3. 3 squared is 9. -7 minus -9 is -7 plus 7. So that's 2. 2 squared is 4. So those end up being congruent. So QR and ST are congruent. And then we're going to look at RS and QT, these two. So RS would be the square root of 1 minus 4 squared plus -5 minus -7. So 1 minus 4 is -3. -3 squared is 9. And then we'll add -5 plus 7 if we make these positives. So -5 plus 7 is 2. 2 squared is 4. So this one ends up being the square root of 13. And so let's check out QT. So QT would be, let's see, -2 minus 1 squared plus -7 minus -9. Okay, so -2 minus 1 is -3. -3 squared is 9. -7 minus -9 is the same as plus a +9. So that leaves you with 2, and 2 squared is 4. So we end up with the square root of 13. So since these are all the same, they're all congruent, this is either a square or a rhombus. So it's a square or rhombus. The question is, are the diagonals the same? If the diagonals are the same, then it's a square. If not, it's a rhombus. So let's take a look at those ones. So we need QS. QS would be -2 minus 4 squared plus -7. -7 minus -7 squared. So -2 minus 4 squared, let's see, -2 minus is the same as plus, so that's 6. -6 squared is 36. And then -7 minus a -7, that zeroes out. So this is plus 0. So we end up with the square root of 36, which is 6. And then the other one is RT. So RT is, let's see, 1 minus 1 squared plus -5 minus -9 squared. So this ends up being 0 squared. So we have 0 plus -5 minus -9 is the same as adding 9. So that would be +4. And 4 squared is 16. So 0 plus 16 is the square root of 16, which is 4. These are not the same. So because these are not the same, it tells you that it is a rhombus. So QRST is a rhombus. Okay, and you can go through these. There's just a lot of distance formula. I think the main thing, remember that these go in order. D, E, F, G is starting in the corner and go clockwise, and those are in order. So that should help you out. And again, you have all of the answers. You can practice these if you get the hang of it. You have the answers in your packet, so you can go on if you're feeling pretty comfortable.